Alright guys, welcome back to our lesson, and we are going to continue from the carbohydrates, which is the classifications of carbohydrates based on the functional group that they contain in them. So we realize that there is only two functional groups that are found in carbohydrates. If it is not aldehyde, then it is ketone. So any carbohydrate that contains the aldehyde functional group, we are calling it the aldose. And any carbohydrate that contain the ketone functional group, then we are calling it the ketose. But if we say ketose, I mean that would be a general name for the classifications of sugars that contains only ketone. Because if you are having this one as a ketose, we can also have another sugar where this time around we are having the number of carbons to be 4. This one will also be referred to as ketose. But then, how do you differentiate it from the initial one that I drew? Then we are going to talk about something based on the number of carbons that they contain in them. So now let's take them one by one and look at the following. Starting with the aldose, or starting with the sugars that contain the aldehyde functional group. Now, using our numeric systems, we are having the di, we are having the tri, we are having the tetra. Tetra means 4, tri means 3, penta means 5, and hexa means 6. At least let's reach that point. Let's all be aware of those particular numerical systems. So if you are saying we should name this sugar in terms of the IUPAC name, then we have to consider the functional group that is containing in them and also the number of carbons that are found in them. So here the number of carbons that are found in this particular sugar is 3. So we are using tri. Okay, so this one being an aldose sugar and it contains 3 number of carbons, then we are referring to it as aldotriose. So when someone says aldotriose, this means a carbohydrate sugar that contains the aldehyde functional group and also has 3 number of carbons. We can also have ketotriose. That is when we are having the ketone functional group. It's having 3 carbons and also it's a sugar. You get it? So let's take a typical example and look at how it works. We can draw, or we can write the structure for an aldose sugar. We are having 5 or maybe 4. So here we are having OH, this side we are having OH, and this side we are having OH, H, H. So now I want you to look at something here. If you look at this particular side, it is the same thing as this, but because I've written this one in the condensed form, you might not maybe actually identify that this is the same thing as this. So always keep in note that we are having what? 1, 2, 3, 4. Here we are having 4 carbons, but here we are having 1, 2, 3, we are having 3 carbons. Remember, the carbon that forms part of the functional group is also taken into consideration when we are counting the number of carbons. So you shouldn't forget about that one as well. Then, if you should name this sugar, because this sugar contains the aldehyde functional group, and it also contains 4 carbons, then we are calling this one aldotetrose. Aldo means it contains the aldehyde functional group. Tetro or tetra means it contains 4 carbons. And O's, the moment you hear O's in the course we are doing, the moment you hear O's, it represents sugar. I think I've mentioned it earlier in our previous lessons. The moment you hear O's, it represents sugar. So don't forget about that one. Let's try and draw another one before we move to the sugars that contain the ketone functional group. So we can have our aldehyde functional group again. We can have 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. Having 6 carbons in all. Here we can have our OH. Here we can have our H. Here we can have our OH, and here we can have our H. This side we can have our OH, have our H. Here we can have our OH, and this side we can have our H. Then this side CH2OH. Now there is something I want you to know. You see how I do this thing? It's very easy. Now this is the structure for glucose. So even if there should be a problem in you studying anything at all, studying the structure, At least learn how to draw glucose. This is the structure of glucose. You are having the first carbon containing the aldehyde functional group, and you are having the second carbon, the OH is on the right, the hydrogen is on the left. On the third carbon, your OH is on the left, your hydrogen is on the right. Your fourth carbon, we are having the OH on the right, your hydrogen on the left. Your fifth carbon, we are having the OH either on the left or on the right. And I'm going to teach you the reason why we can have the OH either on the left or on the right because of enantiomer. So we are going to talk about that one soon. And this one is the last carbon. Remember, this carbon is not a chiral carbon. This carbon is a chiral carbon. Yes. Now let me try and identify it as well so that it will become very easy for us. This one is a chiral carbon. This one is a chiral carbon. This one is also a chiral carbon. But this one is not a chiral carbon because if you try opening it, remember, let's assume that this is the chain. We are having our carbon. We are having our OH. We are having H. And we are having H. A chiral carbon is a carbon that has been bonded to 4 different groups of atoms. But look at this. This one is bonded to 2 identical, which is 2 hydrogens in all. So it doesn't qualify to be a chiral carbon. Now, let's try and name this because this one, the trivial name of this particular one is glucose, like I said earlier. If you try naming it in the IUPAC form, where we are identifying the functional group and also the number of carbons, then we are calling this one aldohexose. Why aldohexose? Because it contains the aldehyde functional group. It's having 6 carbons and it's also a sugar. So that's how come we name sugars. If you are having, let's say, extra carbon, let's say we are having another one, H, OH, before your CH2OH, then we can call this one aldo, no, we can call this one aldoheptose. Remember, I was about to write aldopentose. Aldopentose is more like sugar that contains 5 carbons, but this one contains 7 carbons. So aldoheptose. Now, let's go over it again, how to draw the glucose, because that is the most important thing. If you know how to draw the glucose, you can know how to draw a lot of sugars, because the glucose is different from other sugars, maybe per some differences in position of the OH. That's what I come to talk about soon, which is called the epimers. So let's look at something here. We are having our carbon. How to draw the glucose? We are starting again. Carbon, double bonded to oxygen. Then we are having our hydrogen, followed by our carbon, 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 and carbon. 1, 2, 3, 4, 5, 6. So this last carbon is not a chiral carbon, so CH2OH. Now we start. We are having OH on the right, OH on the left, OH on the right. And this side, we can have OH on the left or OH on the right. I'll teach you soon. So let's put the OH on the right. And here we have our hydrogen, 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 and hydrogen. So that is why we are, so when we are starting with our lessons, we realize that carbohydrates are also referred to as polyhydroxyl compounds. Polyhydroxyl compounds, meaning they are having a lot of OH groups in them, or they are having a lot of the alcohol functional groups in them. So that is just by the way. Now, this is the structure for glucose. So if you are naming this glucose, this one can have a trivial name. Now, I want you to look at something very important here. We are introducing another term called the penultimate carbon. Called the penultimate carbon. What are we referring to as a penultimate carbon here? Penultimate carbon is just referring to the last but one chiral carbon. So I'm referring to this. You see, this one is a chiral carbon, chiral, chiral, chiral. But this one's not a chiral. So the last but one carbon on the chain, or the last chiral carbon, is what we are referring to as a penultimate carbon. So with this, we are having a penultimate carbon. This is our penultimate carbon. So it is on this carbon that we can have our OH group interchanging. If you are having your OH group, if you are having your OH group on the right, then we are referring to it as a D sugar. If you are having the OH group on the left, then we are referring to it as L sugar. So this one, what sugar is this? It's a glucose. So with the OH on the right, we can call it what? D glucose. How did we get the D? We get the D by focusing on the penultimate carbon. Now, when we talk about the ketone functional group or the ketone sugars, you are going to realize that it's not all of them that are having the the penultimate carbon. And you reach there soon. They might not mention it, but I'm mentioning to you now so that you find a way of understanding it very well. So we can have our OH also on the left. And if the O is on the left, then we are calling this one L glucose. But if they ask you to name it in an IUPAC system, if you are naming it in an IUPAC system, then because this one is an aldohexose, then we are calling this one D aldohexose. So D aldohexose and D glucose, they are all the same, as well as L aldohexose and L glucose is also the same. So if we understand this part, then let's talk about the functional group. Let's talk about the other functional group called the ketone. And we are going to learn more about that one too.